All right, can everybody see my iXL? This one is a little bit harder. Okay, so one of these things that makes this a little bit harder is we're dealing with all four of the congruency theorems that we've learned so far. Side, 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 angle, side, angle, side, angle, and angle, angle, side. That's one of the things. All right, so everybody knows I have to draw on stuff, so I need my snipping tool so we can draw on this. And you can do this when you practice in iXL too. Take a snip of it, and then you have a little pen, lets you draw whatever you want, because I'm very visual. It's probably why I love geometry so much. All right, so does anybody see a pair of congruent parts on these two triangles? And if so, name them for me. Just one pair. Okay, let's see, Renaya, I got not KP and MN. Look at these tick marks. It means that that smaller segment is congruent to another one. There we go. Let's see. There we go. So line segment KJ is congruent to JP. Everybody see that? Okay. So we got that one. And that's is that an angle or a side? It's a side. All right. Can y'all find me another pair of congruent parts? All right, not MJ. No. Oh, there, I see it. PN is congruent to MK. Is that an angle or a side? This one right here with its one tick mark. It's a side. Okay. How many, just looking at the names of these theorems, how many corresponding parts do you think we need for each one? I mean, we need one more for this, but for each one, how many letters are in these? 3. We have 2 so far, so we need one more. So let's take our brains way back to all the different rules we've been learning in geometry. Does anybody see a rule that would help us see another set of congruent parts here? We need another side. Do you see the other side that's the other pair of sides? We don't have a marking, and just because J is the midpoint of KP, it doesn't mean it's the midpoint of MN. So nothing tells us that, but that's a good guess. I like how you're thinking. Maybe think about our angle pairs. What angle do you see, Ethan? You don't see any angle pairs that we've learned about that we know are congruent? P and K. Now, I like that thought because if we did have parallel lines here, yes, P and K would be congruent to each other. But I like how you're thinking. It just doesn't tell us that. But who remembers that angle pair that makes an X? Remember what these are called? Not opposite interior. Starts with a V. Vertical angles. Vertical angles are congruent. So that means these two angles are congruent. So angle J is congruent to angle J. And that gives us an angle. Okay. So now we got to match it up with one of these names, right? So do we have one? We have this one that is side angle side, but since the A is in the middle of the sides, who remembers what that means, where that angle has to be placed? Does anybody remember what it's called when it's in the middle of the two letters like that? It's called included. It's called the included angle. And it means it has to be the one that is in between the two congruent, actually. The two congruent parts. Okay. So this one's not our included angle. So what do we have to answer here? We don't have one that matches this one. The angle has to be in the middle of the two sides for this one to work. So what do you think our answer has to be here? We just said that won't work, Jeremiah. Be with us. Yeah, it cannot be proven. We can't use side angle side because the angle is not in between. It's not here in between our two congruent sides. So let's try this. There we go. All right. Now this one, this one's going to get you guys every time. And we did this in class on Tuesday. We did it in class last week. We have three congruent side angles here. Do we have a rule that's called angle, angle, angle? Do we have a theorem like that? No. Do three congruent angles make two congruent triangles? No. You can have congruent angles and still not have congruent sides. All right, so let's go up a level before I let y'all practice. Let's go up a level. All right, this seems to be easier, but we're going to see, okay? So once again, how many sides do we have that are congruent on each of these angles? Hang on, let's draw again. Wait, I want to get this better. Yeah, we have two. We got this one congruent here, KM congruent to HG. That's one side. What's our other side? MN congruent to HJ. Another side. And then we have an angle. Is it the included angle? What does included mean? It means it has to be in between. This is the included angle on both of these. This is not the included angle. Okay? So once again, no. All right? Is this one the included angle? Seems like they're trying to tell us something, right? They want us to know that included angle doesn't work. It has to be the included angle when we're talking about side-side angle, right? It has to be the included angle. Okay, let's look at this one. All right. Oops. I got crazy. Okay, so here we have an angle. Give me some congruent parts that y'all see. Give me a set of congruent parts y'all see here. I see some congruent angles. We're looking HJ. There's nothing that says HJ and GH are congruent to each other. We're looking at the angles. Those little curve marks means angles. Oh yeah, definitely, Madeline. I love it. HF is congruent to HF. That's our reflexive property. So we got a side, correct? All right, do y'all see some congruent angles? Look at those curves. Look at the congruent marks. So basically, angle F is congruent with angle F. That's an angle. And then what's our other set? Angle H is congruent with angle H. All right. So this is where I think this one is a little bit harder than your other ones, okay? Because notice they're not giving you your theorems here to pick from, are they? No. We know we have angle, angle, side, but we don't know if we have a theorem. But we can look up in the title. Does everybody see the title? It has them all listed for us. All right. So what theorems have two angles and one side? Put them in chat. Angle, side, angle, and angle, angle, side. All right. So this one, the side has to be included. See how it's in the middle of the two angles? Has to be included. This one, it can be a non-included angle. Is our side, HF, included or not included between the two congruent angles? Catherine's got a question mark. Does anybody agree or disagree with her? Is this congruent side? I like it, Alyssa. Is this congruent side in between our two congruent angles on the triangle? Is it the included side? Yes, it is. So which one do we have to use? Nope. When it's included, it's in the middle. Yeah, angle, side, angle. There you go. Are these congruent? Yes. All right. Now this one has the same, but is the side included? Is this side here that's still congruent to itself, two angles and a side, but is the side in between our two congruent angles? No, but that's still a theorem. So are these congruent? They're congruent by what theorem? Angle, angle, side. Yes. All right, let's jump up the last level. Okay, so once again, we're just finding our two and completing the congruency statement. So here, which two triangles are congruent? Name our first one. Triangles got 3 letters to name them. All right, I got X, Y, Z. All right, that's this triangle here. Which one is it congruent to? It's congruent to this DEF by the 2 tick marks that show the sides are congruent. All right, so we got to line it up. What angle corresponds with angle X? E. What angle corresponds with angle Y? D. What angle corresponds with angle Z? F. We got it. We definitely got above our 70 to get our 100 in the grade book. All right. So we're going to go back to our class, and I'm going to give y'all some time to work on this yourself.